Hello everyone, this is your tutor AB. Today we're going to be solving a problem from the IB Physics HL examinations. This is a paper 2 problem of 3 parts. Let's get started. A solid piece of chocolate of mass 82 grams is placed in a pan over fire. Thermal energy is transferred to the chocolate at a constant rate. The graph shows the variation with time t of the temperature capital T of the chocolate. At 6 minutes, all the chocolate has melted. So here's a graph that illustrates this scenario. The specific heat capacity of chocolate is 1.6 into 10 to the power of 3 joules per kilogram per Kelvin. So part A. Show that the average rate at which thermal energy is transferred into the chocolate is 15 watts. Okay, so before we get started, let's understand what this question is asking us. It's asking us to find the average rate at which thermal energy is transferred. And what is the variable that corresponds to the transfer of energy? Well, that variable is nothing else but power. And another way to confirm that power is what I'm looking for is by looking at the units. Watts is the unit for power, and so power is what I want to solve for. Okay, what is the equation from a formula booklet that has the specific heat capacity involved? Well, we know a formula Q is equal to mc delta T, where heat capacity is C. Okay, now this still does not involve power, right? I want to solve for power, so how do I do this? Well, what exactly is Q? Q is heat evolved or energy evolved, heat evolved or absorbed, which in other words can be, in this case, energy transferred. Heat evolved is the energy transferred. Now, to put this into perspective, what is a usual variable that we use when relating anything to energy? Well, we know that the change in energy or energy transfer is nothing else but work. Work is the change in energy or the transfer of energy. So, what is the formula for power? Power is work over time. So, work is equal to power times time. Okay? And we know that work is also equal to Q. So, instead of Q, we can substitute this expression right here, P times T. So, power into time is equal to mc delta T. Alright? You don't want to mix up your two T's. One is temperature, one is time. So, solving for power, we get mc delta T over T. Now let's put in all the numbers into our calculator. The mass has to be in kilograms, right? So 82 grams into kilograms is 82 by 1000, so that's 0.082 times by the heat capacity of the chocolate, which is given as 1.6 into 10 to the power of 3 times by the change in temperature. Right, so the change in temperature would be from 45 minus 31, and the reason I take these 2 points is this is the portion of the overall process which is having some sort of change in energy, or in other words, some sort of thermal energy transfer. So that's from 0 to 2 minutes. So in seconds, that is nothing but 120 seconds. So in final, we're doing 0.082 times by 1.6 into 10 to the power of 3 into the change in temperature 14 all over 120. And that gives us 15.3 watts, which is approximately 15. Okay. Part B. Estimate the specific latent heat of fusion of chocolate. Well, in our data booklets, we are given some equation which is Q is equal to ml. Now this, well, L is the variable for the latent heat of fusion. Okay, and what did we know from the previous part of this question? Q is nothing but power times time. So PT is equal to ml. So rearranging this, we get L is equal to PT over m. Right, so we know everything for this specific expression. Power we calculate is 15.3 times by time, and this time is actually different, whereas this time is from 2 to 6 minutes. And the reason for this is because they're asking for the latent heat of fusion. What is the latent heat of fusion? It is the amount of energy something takes to turn from a solid to a liquid, to change state. And we know the portion of the graph where there is no change in temperature is the portion where there is a change of state. And so from 2 to 6 minutes is the time that we are needed for this expression. So that is 240 seconds over the mass of the chocolate, which is 0.082 kilograms. And this, when I put it into my calculator, let's see what I get. 15.3 times by 240 over 0.082. So I get approximately 4.5 into 10 to the power of 4 joules per kilogram. Now be careful with your units. So in significant figures, this is the right answer. And finally, compare the internal energy of the chocolate at t is equal to 2 with that of at t is equal to 6 minutes. Now let's understand what's going on. This is the graph. From t is equal to 2 to t is equal to 6, there is a change of state occurring. So what does that mean? We can see that there is no change in temperature. The temperature from 2 to 6 minutes remains constant. So what does that basically tell us? At t is equal to 2, a change of state changes, a change of state occurs from solid, and at t is equal to 6, it becomes a liquid. Okay, so over this period of time, thermal energy is being transferred to the chocolate. It's being absorbed by the chocolate. And so that's what's happening. So what is internal energy? Internal energy is nothing but the energy within the particle, or within the particle makes sense. Energy within the particle, which is comprised of kinetic energy and potential energy. Now let's look at this. Kinetic energy. Is anything going to occur to the kinetic energy of the particle? Well, no. Temperature is not changing. If temperature doesn't change, kinetic energy does not change either. So Ke stays same. Kinetic energy stays same. However, thermal energy is being absorbed by the chocolate. It's being absorbed to break the bonds that are within the solid particles, or break the bonds that are holding the chocolate as a solid, to then allow it to change state into liquid, because liquid has weaker bonds than a solid. So this is actually increasing the potential energy. But Pe increases because of the change of state and the continual absorption of the thermal energy. So the internal energy increases from 2 to 6. Okay, thank you for watching. Please like and subscribe. If you have any questions, leave it down below and I'll answer it as soon as possible. Thank you for watching.